Hey Lorna, these are my answers, okay? I had to make this really quick. It's late and it's late. Okay. So, first of all, this is not a repeated measures ANOVA. I don't know why they put that down as a repeated measures ANOVA. A repeated measures ANOVA, an example of that would be if you gave everybody a pre-test in depression and then you gave them some therapy. The next week they got therapy, some kind of treatment or something. And then they got a post-test of depression. Hopefully the therapy would have caused that to go down. And then a month later, a follow-up of their depression. So one group, many repeated measures, at least 3 repeated measures. That's a repeated measures ANOVA. This is different. This has 3 different tests in reading, writing, and speaking. So this would never be a repeated measures ANOVA. So I'm hoping I'm not getting anybody in trouble. But again, this, because the tests are 3 different tests, that does not make it a repeated measures ANOVA. So number 1, what is the null and alternative hypothesis? The nulls are always the same, that there will be no difference between the means of the males and the females. In other words, whatever the mean of the male scores will be equal to the female scores. That's the null. All nulls state the same thing, no difference between the means. And the alternative is there will be a difference, because the question, it just says, is there a significant difference? It's not saying that girls will be higher than boys or vice versa. If it was, that would be a one-tailed test, but they're not. So this is a not equal to. Okay, so again, there's going to be 3 of these null and alternative hypotheses, 1 for each of the tests. Okay, number 2, what statistical test will you use and why? I just went over that. These are going to be 3 independent t-tests. The IV is gender, and it has 2 levels. In other words, male and female. And the DV is going to be the proficiency score, but there's 3 different ones, right? 1 for reading, 1 for writing, and 1 for speaking. Okay, this would not be a MANOVA, because your DVs are not strongly correlated between 0.3 and 0.8. Let me show you that real quick. 2 of them are, but 1 of them is not. So that's one of the big rules about running a MANOVA. I don't know if you're there yet, but your DVs should all be correlated between 0.3 and 0.8, unless there's some kind of theory going behind it. And you can see that speaking and reading are strongly correlated, but speaking and writing, not so much. And the worst one is writing and reading. It is only correlated by 0.2, so you would not run a MANOVA here. Let's back to the questions. So I am sticking to 3 independent t-tests. All right, the assumptions. What are the assumptions of the t-test? Number 1, normality. And it looks like all 3 of your variables violated the assumption of normality. Let's go here, and I will show you how to do that. You're going to go to Analyze, Descriptive Statistics, go to Explore, put your DVs in here. You're going to go to Plots, unclick the stem and leaf, but click the histogram. And this is your main one, your normality plots with tests. That's going to give you a Kolmogorov-Smirnov test or the Shapiro-Wilk test. And those are the ones we use around here. You click OK, and you get this stuff. So we don't care about that. Don't care about this. Don't care about the descriptives. But here's your main box. So if you go by the Kolmogorov-Smirnov test, only the speaking violated normality. But if you should use the Shapiro-Wilk, all of these numbers are less than 0.05, which indicates they're all violating the assumption. If that's not clear, look at the histograms. That does not look normal. Remember, a normal curve looks like the bell curve. That's not normal. Don't use that, don't use that, don't use that. Here is the writing. That is not normal. And let's look at the last one. Reading, that is not normal either. So none of the data is normal. They all violated the assumption of normality. Second assumption is what we call independence of observation. There's no way to check that, so you have to assume it was not violated unless you were right there administering the exam. Administering the exam. So what that means is when somebody in one group is affecting the results in somebody in the other group. So an example of this being violated would be if a male was giving a female answers or keeping her from answering the right question. So again, you weren't there. There's no way to check it, so it's always assumed. The last assumption is homogeneity variance. In other words, the spread of the test scores should be relatively the same between the males and females. So we ran the Levine's test, and because none of these were less than 0.05, that means it did not violate. So it did not violate the assumption of homogeneity variance, but it did violate the assumption of normality. All right, next question. Syntax. I'm not a syntax guy, but let me show you what I came up with. You simply go to the test that I was going to run, and it's analyze, compare means, independent samples. Sorry, it's been a long day, so. And you put your test variables here. These are your DVs. And your grouping variables, you always got to define them. So 0 was male and 1 was female. And then you just click paste, and that brings up your syntax box. So again, I'm not good at this. We never use syntax down here, very rarely. So I simply cut and pasted that into this sheet here. All right, what are my decisions in regard to the null hypothesis? So I ran the independent t-test, and these are your t-test scores right here, the t. And here's your sig values or your p values. So if these sig values were less than 0.05, then that would have been an indication that there's a significant difference between the males and the females. But as you can see, none of these sig values are less than 0.05. Therefore, there were no significant differences between the males and females, so you failed to reject the null. Okay, so in other words, the null was probably correct. There's no difference between the mean scores of the males and females. And APA format results, I think he's looking for this, right? This is the formatting. T means you use the t-test. This is degrees of freedom. That's the actual t-test statistic. And there's the p-value. So APA says your test statistics should only go out to 2 place values, and your sig values or your p-values should go out to 3. All right, so present in summary tables. Not sure what he's looking for there. So I think I just put in, you put in the means and the standard deviations. And these are very helpful. Look how close these means are for speaking. They're both 23. So there's not going to be a significant difference here. There's not going to be a significant difference there because they're both 14. And this one, we're only talking like 0.3. That is a difference, but it's not significant. So that's what this is all about. Hope this helps. MGZ out.